In this video, we are going to solve some problems which are related to sets, problems that can be solved by sets or counting elements. So this is the last lesson for our chapter 1, in which chapter 1 still talks about sets. So we have our first problem. So we have here, there are 50 students in a room in which each of these students can choose at least, meaning they can choose either one or two, one shirt from two choices of shirts. So the choices are red and yellow, so they can choose red only, yellow only, or both red and yellow. So suppose we have 31 students chose red and 25 students chose yellow. Okay, so that is the condition. Question number 1 says that how many students choose both. So how do we approach this is that looking at 31 and 25, it goes over 56. And we only have a total of 50 students. How come it becomes 56? Meaning there are students, okay? There are students who choose both, okay? Red and yellow shirts. So out of 56, we have only 50 students. That gives us 6 students choose both. Okay? So number 2, how many students chose red only? So how many students chose a red shirt only? How do you do that? So we know that out of 31 students who chose red, 6 of those choose both. Okay? So therefore, the remaining out of 31, so we have 31 minus 6, that's 25 students chose red only. Okay? How many students chose yellow? The same with the number 2. Since there are 25 students who chose yellow, then we know that 6 of those choose both. So that gives us 25 minus 6, that's 19 students chose yellow shirt only. Okay, so that is our first simple problem. So if you're going to make that in Venn diagram, it goes like this. Okay, this is the 50 students, so they are required to choose at least one. Let us say that's the condition. So like that. So this is the, let's say, the red and yellow. Okay, so we know that 6 of them, 6 students, and we know that the red 25 students and the yellow 19 students. Okay, so that's how we so this is our universal set, the U. So as you can see here, the circle which only covers R but not Y, this portion, okay, this portion, this portion, okay, this one represents the set for students who chose red shirt only. Okay, and the same with this one. This is the set of students who chose yellow shirt only. Okay, and the 6 students, this is for both red, they chose red and yellow. Okay, so it's like that. Next problem number 2. Out of 30 teachers, okay, there are 30 teachers, each is teaching at least one subject. So some teachers are teaching either math only, science only, okay, or there are some teachers out of the 30 teachers teaching both science and math. So the condition says 23 teachers teach math and 8 teachers teach both math and science. Okay, remember we have we have a, what do you call this, a 30 teachers in total. So considering 23 teach math and 8 teachers teach both math and science. So if we're going to solve that using a Venn diagram, so I said this is math and this is science. We know that in the problem, we know that 8 of them teach both math. Okay? Here, the concept says 23 teachers teach math. It doesn't tell us 23 teachers teach math only. They teach math. The 23 teachers teach math, not math only. Okay? Meaning, we cannot just write 23 here. Okay? Because we know that 23 already includes the both. Both teachers, teachers teaching both math and science. So that gives us here, instead of writing 23, okay, instead of writing 23, we subtract 23, 8, that's 15. Okay, 15 teachers. 15 teachers. Okay. So the question is, how many teachers are teaching science? So we need to get the value here, the number of teachers here who are only teaching science. Okay, that's actually the number. Okay, so that's the number 2. How many teachers are teaching math only? That is actually the 15. So we can answer it as 15 teachers. Okay. The question is, how many are teaching science? Okay. So if we're going to add this, okay, if we're going to add this, it should be 30. So what is lacking so that it will become 30? So that is 15 plus 8, 23. To become 30, that should be 7 here. Meaning, there are 7 teachers teaching science only. Okay, remember, there are 7 teachers teaching science only. But the question here is teaching science, not science only. So that gives us 7 and 8. So that's 7 plus 8, 15 teachers. Okay, 15 teachers. So that is how. Next problem. The next problem is all about symbols. Although it's the same with 1 and 2, but in 1 and 2 it is presented in textual form. Okay, in language form. But in number 3, like this, let's try to use symbols, set symbols to, answer the following problem. So to begin with, let's establish first our definition, our not really definition, but what do we actually mean by this? Okay, so we have A here, then there's vertical there, vertical bar, enclosed with vertical bar. It means that there are 5 elements in set A. So the bar denotes cardinality. You know cardinality? Cardinality means the number of elements in a set. Okay, so that's cardinality, meaning how many elements are there. So in this case, there are 5 elements in A, suppose. So in A minus B, there are 7 elements in set A minus B. So that's how we mean it. So when you say we put this bar, last time during our lesson 2, we also note that n of A is the same as this. I think that is lesson 2 or lesson 3 in finite set, about the finite sets. So let's go on. So here we have in set A only, okay, so here 5 elements, then 3 elements for both, then 7 elements for B only, then 2 elements for not really A, not for A or not for B, neither A nor B. Okay, so let's try to list how many elements for A. Remember, A is the whole circle, so that's 5 plus 3. There are 8 elements. Okay, let us say for B. Let us say for B that the entire circle for B, that's 7 plus 3, that's 10. Okay, so how about you say A union B, meaning let's combine all A and B. That is 5 plus 3 plus 7, that gives us 15. Okay, so there are 15 elements in A union B. There are 10 elements in B. There are 8 elements in A. There are 15 elements in A union B when we try to combine A union B. How about how many elements in A intersection B, the common. So that is 3. Okay, so that's basically how do we read the Venn diagram, turning them into symbols. Okay, so how about if we have A complement? Okay, A complement means what are those, how many elements, okay, are there in the universal set which is outside A. Okay, it's an element of the universal set, but it's outside of A. So what are those outside of A circle? That's 7 for B only, and 2 for outside of the circles. So 7 plus 2, that is 9. Okay, how many elements are there in B complement? So B complement outside B, okay, that is 5 and 2, that is 7. Really good. How about if we say A union B complement? So if we are going to combine A union B, what is, how many elements outside of this combination? So we already know that outside, so the union of A and B is the entire 2 circles. So what is out, how many elements outside that 2 circles? So basically that is 2 elements here. Okay, how about if we say A intersection B? Then that is complement. Okay, A intersection B complement. So what is outside of that? How many elements outside the intersection? So intersection is 3. Outside that, 5, 7 plus 2, that gives us 14. Okay, how about if we say A minus B? Okay, only A, not including B. It's like saying, what are those A minus B, the set A minus B in before, in the lesson 5, it means that what are those elements in A that are not present in B, that are not present in B, only in A, not in B. Okay, so this, in this case, since we say, we talk about cardinality, it means that how many elements are there in A only, not including the B. Okay, so that is 5. Okay, so notice that this one is saying A only. Okay, the same, so we say B minus A, meaning B only, that's 7. Okay, so those are basically some set operations and counting how many elements are those using Venn diagram. So let's continue with this. So let us say A again. That's the entire circle A. That is 10 plus 6. That is actually 16. Okay. So A minus B is A only. That's 10. Okay. How many elements in A intersection combination B? That's 10 plus 6 plus 8. That gives us 24. Okay. Okay. B complement. Outside B. Okay. Outside B is 10 and 4. That's 14. Okay. Outside A combination B complement. That's outside of that. That is 4. Okay. So basically that's how we write. Now let's proceed with the next problem. So if so this here there is no, it's getting more abstract. Okay, it's getting more abstract. So as you can see in the first problem, I provided you with textual problems, okay, or worded problems. So it's kind of easy for us to really, you know, understand because it's in textual form. Then I provided you with a lesser textual, but there is an aid of the Venn diagram for 3 and 4. But this time, let's bring it to a little bit more abstract. Okay. So if A, so of course, we can make use of Venn diagram to visualize this problem. So if A, so that's why I discussed to you the 3 and 4, okay, the relationship of these cardinalities and the Venn diagram there, so that we can actually, will be able to answer 5 and 6. If there are 9 elements in A, the entire circle A, and there are 8 elements in the entire circle B, and if we're going to combine all of this, we only have 14. Okay? Remember, this is combined. Okay? Find A intersection, meaning common. This is combined, then common. Okay? So if we're going to use a Venn diagram, see that? This is A, this is B. If we're going to combine all of this A, B, this portion, so I'll take note of that. This portion plus this portion plus this one, we only get 14. But if we're going to add 9 and 8, that's over 14. So this is, if we're going to add the 2, it becomes 17. And we only have a total of, because it's combination of A union B, it's 14. Meaning, there is, the same with the very first problem a while ago, there is a, there are some overlapping. Okay, so that is 17 minus 4, that's 3. Meaning, this 3 is actually for that. Okay, remember, if we're going to combine all of this, we'll get 14. Okay, so as you can see, A, guys, we have 9. But we already have 3 for both. So this means the A only is 6. Okay, 6 elements. So I'm not, 3 is not an element, the number of elements. I write it elements. Okay. Then for B, the entire B, remember, for the entire B, we have 8. We already have 3 for both of A and B. That makes us 5 here. 5 elements. So that's basically how do we answer this? Common. So A intersection B is simply 3. Which just get it from here. Okay. Next and last. So I think there's a need for us to draw our, okay? If the entire circle A is 10, the entire circle B is 7, but B minus A is 5, meaning B only. There is a need for us to understand what's the very layman's term meaning of this. B minus A meaning how many elements are those in B but not included A. Okay? So B only, it means we're talking B only. So that is, it's 5. It's 5 here. Okay? So the entire circle B is 7. How come the entire circle B is 7 and the B only is 5? Meaning the common is 2. This logic and that. Okay? This one, that's the entire circle B. But the B only, not including A, is 5. Okay? Taking away the both, which is for A, which is 2, 5. So therefore, the common, the intersection is actually, we already have answers here, that's 2. So, since in entire circle A, it tells us here, the entire circle A is 10, and we already have 2, that makes us 8. This makes this A only, 8. So, A, this should be, yeah, of course, this already the given, it's 10. So, A complement, meaning, A complement outside A. How many elements outside A? So this is the entire A. What's outside? 5. So it's like saying A complement is just equals to B minus A. The same idea. Huh? So A union B, of course, A union B, let's add all. 8 plus 2 plus 5 will get 15. Yeah, 15. Then already we have that. So that's how simply we try to solve problems involving sets. There are still a lot of problems involving sets, but for this level, let us stop for this level first. See you in the next chapter. Okay, and the next chapter will talk about more on real numbers.